Hello, folks. So we are back again, and we are back with yet another mock interview round. And again, we have Dave here at the hot seat with one more question, which he is going to attempt today. The question again is simple, but the reason why we selected this was it has multiple unique solutions, which all have different methods and which does touch base on different techniques. So I think they will sort of walk us through all of those. And the question is that we are given an array, which contains different integers, and the property of this array is it contains every element has a copy of it except for one. So every element would appear twice, just barring one, and our job is to find that one element which is not repeating. So I'll hand it over to Dave. Probably we'll take on from here. Hey Dave, over to you.
Okay, thanks, Mohammed. Okay, so let me take an example here.
Mhm.
So let's say if I am given an array of integers, okay, so let's say 1, 2, 3, 4, 5, and then all elements except a single element. So let's say 4 is present, 3 is present, 2 is present, 1 is present. So 5 is the one which is a unique element in this array, right? So
And our
uh,
ask is to basically return
find
return
right.
five. Yes.
Okay, so if I write a prototype of the function, it
Mm-hmm.
would be something int sol or find unique,
Mm-hmm.
right?
Mm-hmm.
And then I am given int array of all the elements,
Got it.
and then if not, I am also given the size of the array,
Right.
right? And I need to return unique unique element.
Some, yeah, makes
Okay,
sense.
okay, so I think it's given that it's non-empty, so at
Mm-hmm.
least one element will be there.
Mm-hmm.
And then given that only one element is
Mm.
unique and not more than one, so uh, I think one of the few first approaches I could think of is using the hash, right?
Okay.
So what I can do is I can keep the count of each element,
Mm-hmm.
right? Let's say I visit one, so I uh, maintain a count of one as one.
Mm.
Then I visit two, the count for two would be one,
Mm.
right? And
So on.
until
Mm-hmm.
fifth point, right? So
Mm-hmm.
then when five and after five, let's say four comes again.
Mm.
So now the four is coming again,
Mm.
right? So what I can do is I can increase the count to two, right?
Mm.
For four, and then three, like similarly this way,
Mm.
every element will have a count more than one, which is two, except
Mm.
element five, right?
Mm.
So what I typically do is just iterate through the array and then maintain a counter
Right.
corresponding to that array. And and here counter is similar to hash, right? So it's
Mm-hmm.
in the hash I would have one to one mapping, uh, and then this, so in the hash I have key and value, right?
Mm-hmm.
So here value would be counter,
Count.
right?
Mm.
The number of times that element occurred, right?
Okay.
And then key will be the value of that
Mm.
integer, right? So in this way I can just have, let's say, this counter or count, and then this would be size or the max element,
Mm-hmm.
right? Okay, man. Maximum
Sorry, what is
element.
maximum element here?
Here the max element is, so since we have key as the index of the array,
Mm-hmm.
right? So we need to figure out whichever is the biggest integer in this
Mm-hmm.
array,
So basically, max
and then
element is the domain of the values which
right,
can
yeah,
occur in the array.
right.
Okay.
And hopefully there is no
Mm.
negative integers, that what I'm assuming here. Then
Mm-hmm.
if there is a negative integer, then my key will be different, right?
Right.
I
Right.
need to use some sort of hashing there,
Mm-hmm.
because it cannot be one to one mapping,
Correct.
because array cannot have a negative index, right?
Index. Right.
So
So
I'm
let's
assuming that,
assume,
yeah,
yeah, let's assume that there are
yeah,
no negative integers.
yeah.
So fair enough assumption.
So okay, let me write this. The assumption is non negative
Mhm.
integers. Okay, and then also it does not exceed, let's say, whatever memory I'm allowed, right? So if I'm allowed 1 MB memory, then divided by 4, right? Considering that the integer is of 4 bytes, so 1 MB divided by 4, and that many number of elements I could have in the array, right?
Correct.
So given that it does not, the maximum element does not exceed
Hmm.
that 1 MB divided by 4
Hmm.
value, right? If it exceeds, then I am accessing some memory which is not allocated to me, right?
Hmm.
So that's the another assumption.
Okay, so
Or yeah,
are you
so
planning to allocate this array dynamically or
uh,
statically?
I think uh, okay. So if I am given the max element, like
Hmm.
the domain or the range, whatever you can
Hmm.
say, if I'm given you know before starting, then I could use it as is, allocate this array on a stack, or I could say, declare or define this array as static.
Okay.
If I am not given that value, just like here
Hmm.
I'm not given that value, right? The maximum element in the array. So here I
Hmm.
have to figure out what is the max element, and
Hmm.
then allocate those many number of elements, right?
Okay. I
So
think those
that's,
are fair
yeah,
assumptions.
yeah.
Maybe you can just assume that and proceed
Okay, the second assumption was that we have enough memory
at our disposal.
for hashing,
Mm-hmm.
one-on-one hashing,
Okay.
right? I think I could have a different way where I can use another hash function and then
Mm-hmm.
do the hashing as well, where
Mm-hmm.
I can have a limited memory and then
Mm-hmm.
still use this counter
Mm-hmm.
mechanism, right? So here I'm considering that I have enough
Right.
memory and the max element does not exceed
Hmm.
that memory limit. Then
Hmm.
it's simpler that I have a counter for each element, and then I iterate over the counter to figure out which is the unique element, or the element which has count value 1, right? And
Right.
I return that way
Right.
element. So that's the solution. Do you want me to
Yeah. Yeah. Just go ahead with them
okay,
whenever you feel.
okay. So okay, then I what I can do is int
Mm-hmm.
size of array, or okay, I am already given size, so I don't need to calculate that. So what I could do is I just
Mm-hmm.
iterate over this array int I man n I plus
Mm-hmm.
plus, and then I maintain a here. Let's say I am already given the max element, so instead of here I could have it here, and this is part of the code. So code begins here,
Okay.
right? So I have this max element
Mm-hmm.
somewhere defined, max element, and this would be, let's say, 0x 1.
Maybe use.
Let's say some value. Okay,
Hmm.
yeah, you were saying something.
I think can you use decimal instead of hex because just because all of our values are in
Okay,
decimal.
okay, so let
Some
me say
ten
it's,
thousand. Yeah. Some
yeah,
big
10
number.
to
Yeah.
the power 5,
Mm-hmm.
let's say.
Okay.
Okay,
Mm-hmm.
and then I can have count
Mm-hmm.
an array, then I
Mm-hmm.
plus plus, right?
Mm-hmm.
Before I do that, since it is static, right? So this memory will be allocated
Mm-hmm.
in the data segment,
Right.
uninitialized data segment. So this will be initialized with 0,
Mm-hmm.
initialized with 0. So this would have my count across all the elements, and
Right.
then what I can do, oh man, so this time I
Mm-hmm.
have to iterate through
Mm-hmm.
uh,
Mm-hmm.
max
Mm-hmm.
element,
Mm-hmm.
uh, if count I. is equal to 1, then I can do is return I. Okay, that would be my unique element.
Okay. And maybe a small typo on line 20.
Okay, return -1 maybe. If
Do you think there will be any, given the assumptions in our problem statement, there
okay,
won't be any such condition,
yes,
right? We'll
yeah. So
always
I
find,
don't think there would be any such case where you
but it's still
reach.
good to
Yeah,
think of all that. That's
yeah,
a nice
yeah.
point.
So okay,
Line 20, you missed the
20
iterator
is
I
int I.
and
Okay,
I. That's it.
okay,
All right. So
yeah.
I think the solution looks, perfectly fine to me. Can you
Mhm.
maybe go over the pros and cons of this?
Okay, so here I think when I was writing
Mm-hmm.
this code is something which looks very unoptimized to me,
Mm-hmm.
right? Let's say
How
you
so?
are given only two
Mm-hmm.
elements, right? Just let's say you gave 1,
Mm-hmm.
then 10 to the power 5,
Mm-hmm.
and then 1 again, right? So this
Mm-hmm.
is a unique element, right?
Right, right, right.
But then what I'm doing is I'm taking this much time
Mm-hmm.
complexity to figure out, right? And this much space
So
complexity as well,
basically, our second loop is running till 10 to the
right?
power
Yeah,
5, no
yeah,
matter what,
yeah. Regardless of the input,
regardless. Yeah.
it goes until max element. So that is something off-putting for
Mm-hmm.
me, and I think I need to
I think in your
optimize that.
example, can you do uh, instead of, so our example would have worked, whatever you're trying, the point you're trying to prove would have worked if your last element was also 10 to the power 5.
Right. Last
Right.
element as in
Like third entry would, because in our case, it would return only, because you're checking on line 21, right? One would have
yes,
been,
yeah,
so if it is
yeah, of
one, yeah,
course,
yeah, you are right,
yeah,
you are right.
yeah.
Makes sense.
I think that's the best case if
Base
we
case,
have,
yeah.
let's say, 10 to
Hmm.
the power 10,
Hmm.
like 4, 5
That's
here,
the
right?
best case. Huh?
Yeah, that's the best case, but still,
In
space
some
wise,
of the
it will
cases, you
take
will
that
have to.
much.
Correct,
Yeah,
correct.
space wise, it will take that much
Right.
again.
Mm-hmm.
So this is something of putting for me,
Hmm.
and I think this will be resolved if I use hash, right? So then I wouldn't have to go until max element, but
Mm-hmm.
instead I could have a hash size, and I could
Mm-hmm.
only iterate through that size,
Mm-hmm.
right? So instead of here, let's say, so I'm just explaining how
Okay.
the hash I'm thinking would
Sure.
work out here.
Go ahead.
So let me take here. So let's say I have a hash of, let's say, 10 to the power 4. Uh, let's say this is my count. So this is, let's say, int hash, right?
Mm-hmm.
And then I use some mechanism. Let's say if a number is given to me, int is the number this. So what I do is num percent,
Mm-hmm.
whatever max size is
Mm-hmm.
here. So here this is the size.
Mm-hmm.
Let me say this is hash size, right? And here define hash size 0x4, right? So this is, let's say, hash size. Then this would be my index of that
Okay.
hash,
Mm-hmm.
right? So any element I want to push into hash, I would have index as num percent hash size. So whatever
Okay.
remainder of that size will be my element. So here, if let's say even I've given a big number, let's say this number, right?
Mm-hmm.
So what it could do is it would eliminate, it would count the or calculate the remainder,
Right.
consider that as an index, and push that element there.
Hmm.
Now there is one more issue here is that we will run into some collision here,
Mm-hmm.
because it might calculate the same index for more than one elements, right?
Mm-hmm.
And for that we would be having some sort of, let's say this is hash, so instead of int I could have a pointer,
Okay.
so int pointer, right?
Okay. So instead of storing just the
Right, yeah,
integer value, you
yeah,
plan to store an address.
yes. So
Okay.
then this will have a list of all the elements, right, where my
Hmm.
collision have
Oh, okay.
occurred.
So all the entries which
Hmm.
had the same remainder, so to speak,
Yeah, yeah,
would obviously have the same entry in the hash table, but
right,
then you sort of chain them together, which
yeah,
to
yeah.
resolve
So
the
here,
collisions.
yeah, so here it would have that number and
Mm-hmm.
then corresponding count,
Okay.
right? So if it's hash calculated to be
Mm-hmm.
0, or
Hmm.
index was calculated to be
Hmm.
0, right? Similarly, like it would go on until 10
Hmm.
to the power or whatever this hash size is, right?
Right. So maybe you can draw, one or two more,
Yeah.
just so
Okay, let me have one more.
next time. Yeah. Awesome.
Yeah.
Hmm.
And then so on,
So
right?
basically, what you're saying is this is what our hash map looks like, and it will
Yeah.
end at 0x FFFF. I
Right.
think how many 4Fs, right? It would end at this index would end at four
Right.
Fs.
4Fs. Yeah.
Yeah, and all of those hash table entries can itself have a linked list
Right. Yeah.
of all the colliding
Right. Yeah.
nodes. Okay,
Yeah.
makes sense to me.
So here the hash 0 is this, hash 1
Right.
is this,
Mm-hmm.
and it is pointing to a linked list
Mm-hmm.
of pairs, right? So
Mm-hmm.
this is a list of all the nodes which has the collision over index 0, right?
Mm-hmm.
Right, and then it could go on until all
Right.
f. Yeah.
Man, this is nice. And I want to add one thing. Whatever Dev has described here is loosely how associative arrays and dictionaries and all of those high-level data structures are implemented in
Yeah.
the standard libraries of those programming languages.
Right.
They
Yeah.
have some different mechanism of solving collisions, but essentially that's what happens under the hood. So
Right.
yeah.
Yeah. Yeah. So I think here this problem
Hmm.
somewhat solved,
Hmm.
because then I will have to iterate only until these many number of
Right, right.
elements,
So you're
right?
putting a bound on
Bound
how many
on
times you want to iterate
right.
the second loop,
Yeah. Yeah.
right?
Here we assume that this max
Hmm.
element is this size, right?
Right,
Now
right.
it could be of, let's say, 10 to the
Hmm.
power 9, right?
Hmm.
And still I would be able to push it into this hash and
Right.
calculate the count,
Right, right.
right?
So maybe I think we are already 20 minutes in, and asking you to code the entire stuff would be
Okay.
too much of a time. But
Right.
maybe just for our reviewers, can you quickly walk through like a dry run of the earlier example, how it would look like in our new proposed strategy?
Okay. So in this case, okay, let me quickly copy this.
Hmm.
Okay. And then paste it here. So let's say in this find unique, I'm going to write very low level pseudocode, a very
Or
high level
maybe
pseudocode.
a
Right?
very
Yeah.
that is also fine. Whatever way you like. I was maybe
Okay.
thinking if you could,
Okay.
use the earlier example,
Yeah.
the one which you had, in line 2 or 3, and maybe
Okay.
give a dry run. Yeah, of
Oh, okay. Dry run
how it
on this
on
example,
the
you mean?
yeah.
Okay.
I think that would provide a better mental
Okay.
picture.
Yeah. Instead of providing the code, this
Providing the
should be
code.
better.
Yeah.
Okay. So what I am doing here is
Hmm.
that uh, let's say I have, okay, so here I also need to explain the collision. So I
Hmm.
will take hash size as 4, let's say 4,
Okay.
right? So then the 5 will be somewhere colliding with 1
Colliding.
or 2, right?
Right. Right.
It would be at 1. And then what I typically do here is that I will have this array
Hmm.
of elements.
Hmm. Hmm.
So here currently all these are pointing to null,
Hmm.
right? And then leave this part out.
Hmm.
And then this is again pointing to null,
Hmm.
right? And leave this part out.
Right.
I just want to, so 1, 2, and then all other elements I'm going to push it here.
Hmm.
So okay, hash size is 4, 2, 3, 4.
No, no.
So these,
1, 2, 3. Right.
okay, 1, 2, 3. Okay.
Oh.
Yes, and
Maybe we can.
these are not there.
Right.
Okay, so when
Hmm.
one comes, what I do is I would calculate the one remainder 4,
Hmm.
which is again 1, right?
Hmm.
So I will go into this
Hmm.
hash table at index 1.
Hmm.
Now this is my hash table
Makes sense.
at index 1, and then
Hmm.
push this element 1.
Hmm.
Okay, 1, and then count is 1,
Hmm.
right?
Hmm.
And then this will be removed.
Yeah, yeah.
So
So now
this,
instead of null pointer, we have
yeah,
a node. So
yeah,
it would, you can imagine, a structure node which would have two values.
yeah,
One would be the index,
yeah,
what we pushed, just because it will be more clear when you discuss the collision case.
right, yeah,
And secondly would be the count. How many times have we seen that number
yeah,
so far?
yeah.
Okay. Right.
So the next time when
Hmm.
the 2 comes, the
Hmm.
2 remainder 4 is
Hmm.
again 2.
Hmm.
So 2 will be pushed here,
Hmm.
and then this value will be 2.
Right.
And then when 3 comes, similarly 3 will
Hmm.
be pushed here because it is again
Hmm.
uh, remainder comes to be
Right.
3, and then 4 comes, it will be pushed here,
Hmm.
right? So 4 and 1, so
Right.
4 and 1, right?
So
Here I
far,
am
I'm
storing
understanding
4
it. Hmm.
because then just having this index doesn't
Yeah.
really
Yeah.
give me the value of
Yeah.
that element, right?
Right. Right. Right.
Yeah. And
Makes
then
sense.
5 comes, what I do is I will be pushed a new element
Hmm.
here on 1, because 5 remainder 4
Hmm.
is 1,
Hmm. Hmm.
so I will be pushing new node here,
Hmm.
right?
Nice.
So this will be 5 comma
Hmm.
1, right? And then when 4 comes, what I do is I increase the count to 2.
Hmm.
Then 3 comes, I increase, go to 3, and then iterate over this list, right? So when
Hmm.
4 came, I iterated over this
Hmm. Hmm.
list, and then wherever I found the
Hmm.
key value to be
Hmm.
4, I increased that count.
Hmm. Hmm.
Here in case of 3, I would increase this count 2,
Hmm.
and then next element is 2, so when 2 comes, I increase
Hmm.
this value 2,
Two.
and then 1 comes, I go and iterate over this list,
Over this list.
and then compare it with the key.
Hmm.
5 is not the 1 is equal to
Hmm.
1, so I increase this value,
Hmm. Hmm.
right? And then after I have exhausted the list,
Hmm. Hmm.
what I do is I go over the
So
hash
basically,
table.
so what line number 44, 45, 46, and 47 was the first loop, was the result of the first
First
loop in
loop,
our previous code, right? Okay.
right? Yeah. And then what I do is I iterate over this
Mm-hmm.
list. So there would be two iterations. One is over this for
Mm-hmm.
loop 0 to 3, and then within that I will have a pointer to this first node. So I will iterate over this list
Right.
as well,
Right.
right? And then wherever I find a count more than one, sorry, a count equal to one, I
Mm-hmm.
would return that value, right?
Mm-hmm.
So here the 4 count was more than one, so I just go ahead, and then since it's null, so I then go back to
Right.
the next iteration, which is 1, and then
Right.
go over this and then see, okay, 5 has count 1, so I will return
Right.
1, sorry, 5,
Right.
right? So this is where the loop ends. But let's say it's just like for loop, for hash hash table, and then another for loop for
The linked list
iterating,
inside.
yeah, linked chain. What do you call it?
Chaining.
Chaining, chaining list.
Traversal.
Yeah, for loop,
Mm-hmm.
for linked chaining list traversal. Yeah.
But here, Dev, I think the approach is definitely novel. I
Mm-hmm.
can see the space being saved, but
Mm-hmm.
I think we have missed one slight point where we started off with reducing the time traversal as well. But here I
Mm-hmm.
do see that even though we have sort of redistributed our hash,
Right. Yeah.
and each index has sort of a link list,
Mm-hmm.
and we are traversing all of the nodes in that link list for every
Right.
index. So
Okay.
basically, we are doing the work for every element, right?
Right.
Now, can we do something to cut that out? Given that in the question we know that all the elements will be coming twice except for one.
Okay. Right. So, what I can do here is that since
So we
you
can see a
mentioned that,
pattern here that all of
right.
those, see in our hash table, sort of mini hash
Mhm.
table, we have all the elements with count 2 except one.
Right.
So
So,
maybe you can leverage that.
so what I can do is, instead of increasing the count from 1 to 2,
Hmm.
what if I delete that element, right?
Hmm.
So that element never
Because
comes again, right? So I
because
can
we
just,
never no longer need that to be tracked. Hmm. Hmm.
so when the first element 1
Hmm.
came, I
Hmm.
just added
Hmm.
1 comma 1,
Hmm.
right?
Hmm. Hmm.
Or I just added 1,
Hmm. Hmm.
and then when 1 again came, I just removed that 1 from the list,
Hmm.
right? So then there is no 4 comma 2, there is no
Hmm.
4, 2 comma 2, there is no 3 comma 2 in the list
Hmm.
after I have added everything. So
Hmm.
only
Hmm.
one element is there. Oh man. So then, so okay, so what I'm doing here is that I'm canceling out an
Right.
element with another element,
Hmm.
and that could be done by XOR, man. Okay.
Hmm. 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 We'll
Yeah.
come to that part later, maybe. But I
Okay.
think let's complete this approach
Okay,
first.
of course.
Yeah.
So, what I was thinking is that since this is there, and then what I'm doing here is that when I added, let's say I maintain this hash, right?
Maybe copy over. You can copy over the earlier
Yeah.
hash.
Okay.
Yeah. No. No, no.
Yeah, this
The
one.
one above. Yeah.
Yeah. So what I did was, so initially everything is null for
Hmm.
me,
Hmm.
and then okay, okay. So initially everything is null for me,
Right.
and what happened is that when one came, I just pushed a single element one here,
Hmm.
right, in the list, and then when two came, I just pushed two element here, right,
Hmm.
and then when three came, I pushed three here, and then when four came, I pushed four here, right.
Okay.
So far you are with me,
Yeah,
and
yeah, I
then
am.
when five came, what I did was I did five here,
Okay.
right, in the list at the front,
So this is still a linked list, but
right,
instead of maintaining count, because count does not hold any value to us, we
right,
know it is either going to be two or one.
hmm,
We are eliminating the count storage. We just store the index.
right,
Right. Okay.
yeah,
I'm with you. Yeah.
and then so what I'm anticipating here is that since we need the removal, so we would also
Right.
need a doubly linked list,
Yeah.
because
Yeah. That's a fair point. Yeah.
when
Yeah. Yeah.
let's say
Makes
there
sense.
is this point, let's say
Yeah.
I'm just taking an arbitrary
Right.
example, let's say 7 is here,
Hmm.
and then let's say 9 is next, right. This is just an arbitrary example
Maybe can
where
you change that 7 to
this is
uh,
9, this is 13,
5 and 13? Yeah.
right, yeah.
Hmm.
So if 9 came and then
Hmm.
13 came, I added to the list,
Hmm.
but then when I remove, let's say 9 came again, so I
Hmm.
wanted to remove this,
Remove
so
9.
now I can go to this element,
Right. So instead of traversing the entire list, you want
right.
to basically do it in O of 1, and that's why you want
Hmm.
doubly linked list.
Okay,
Is that
this is not what I wanted. So okay, let me do one thing, is that I will maintain a doubly linked list here.
hmm
This will be a lengthy solution though, but let me go ahead with that. So I will maintain a doubly linked list of nodes, right, and
okay?
then what I can do here is that I will have all these elements, I will have a pointer
Oh.
uh, to that
Mm-hmm.
doubly linked list, the node in the doubly linked list, right.
Mm-hmm.
So when my one came, what I did was I added one. Let's say this is node A. So the first node is A, let's say. So I pushed A comma 1 in the list,
Mm-hmm.
right? And A is the address basically.
Mm-hmm.
That's what I'm saying. And then I added here A.
No, no, on
Put
line 58.
address of A. Okay, yeah. Address of A here. And then
I see.
when 2
Hmm.
came, so
Hmm.
this is pointing to null
Null, yeah.
initially. I'm just not writing it because
Hmm.
I want to save the time.
Mm-hmm.
So when 2 came, what I did was I added this to the doubly
Mm-hmm.
linked list, right? uh, b comma 2, okay,
Mm-hmm.
uh, b comma 2,
Okay.
right, and then I added address of 2 here,
Address of B.
yeah,
Yeah. Mm-hmm.
and then when my next element, okay, let me
Mm-hmm.
remove some of the elements so that it would be faster.
Mm-hmm.
Let's say this is only the case 3,
We add 3. Yeah.
yeah, and then when 3 came, I added that to the list,
Mm-hmm.
right, uh, c comma 3, right, and added 3 here, c address of the c here, right.
Mm-hmm.
When 2 again came, what I did was I went to this list,
Hmm.
right, and then since I knew that okay 2 is present
At that address.
at address b,
Mm-hmm.
so I will go and remove this element from the list,
I see. I see.
right. So what I'm the reason I'm using this hashing is that
Hmm.
I want to reach to that node
In O of 1.
in O of 1, right.
Mm-hmm.
So I am making that linking between this
Mm-hmm.
hash table and doubly linked list.
Mm-hmm.
This is hash table,
Right, right, right. And that's a nice approach. You are basically doing another level of indirection.
right. So when
Hmm.
2 again came, I just removed
Yeah,
this, right,
remove this.
because it was doubly linked list, so I
Right,
could
right,
have removed. If it
right.
were single linked list, I couldn't have removed
Correct,
because I
correct,
didn't know the previous one, right.
correct, correct.
So I removed 2
Hmm.
here.
Hmm.
Then when 1 came, what I did was, so here I removed 2, so here it would be null, let's
Null.
say. And then when 1 came,
Hmm.
I went to a address, so
Mm-hmm.
I went to this index,
Yeah.
found out this address of 1,
Hmm.
went to this position, removed this from the list,
Hmm.
right? And remove this from here as well. And then my list exhausted, and only single entry is there in the WLA list,
Ah.
right? So in this way, I don't have to now go and iterate over the hash table. I
Hmm.
would just find only entry present in the WLA
Hmm.
linked list
Hmm.
and return that,
Right.
right?
Right. Right. Right.
So that's what I'm thinking.
That's a very, I think that's a very novel approach, man.
Yeah.
I like it.
Okay.
Okay. And yeah, so basically we have kind of reduced our time complexity to O of n completely,
Yeah.
but we still have the space which
Yes.
needs to be
So
optimized.
right. Yeah. So
And
we
I
are
think you
still
have
using some
already,
space,
yes,
and yeah.
yeah, I want to pause you here, and you have already given hints, to attentive viewers who were listening somewhere, I think 5 or 10 minutes back. But we don't want to reveal the
Yeah.
craziest solution. It involves bit manipulation and
Yeah.
some operations, bit level operations. Given
Yeah.
the property of the problem, it won't work on the usual case. And the only reason why we wanted to touch base on the both of these solutions is because this will work for any case. Let's say you have you know multiple array entries which are present single time, right, instead of one. Let's say you
Right.
have to find 5 or 6 such entries, right?
Hmm.
Then basically, if you know how to implement a general solution, that would help. But
Right.
maybe they can you scroll up
Yeah.
to the problem statement. Given that we have this problem statement where we only know that there is only single
Right.
element which is going to repeat once, rest all of them will be repeated twice.
Right.
Given this property, there is a very nifty trick for bit manipulation, and I think we would want you guys to just sort of attempt that. Maybe answer it in the comments, and maybe in the next video we can quickly cover that in 5 or 10 minutes. What do you say there? Okay.
Right. Yeah. Okay. I think we are good.
Yeah. Okay.
Yeah.
Nice, man. Thank
I
you
think
very much.
these
I
these
really
all
like the second
solutions,
approach.
yeah,
Yeah.
these all solutions are overkill,
Yeah.
given that we have a very simple and tricky
Yeah.
solution here.
But
Yeah.
I like this because let's say if I change just a slight
Yeah.
condition,
Of
every
course.
element appears twice instead of
Yeah.
that. Let's say it appears thrice. Then what do
Yeah.
you do?
Yeah.
Then your generic approach of maintaining count, you can
Right.
basically tweak some if conditions and get that done. But
Yeah.
you know
Yeah. That trick won't
won't
work
help.
all
Yeah,
possible ways. Yeah.
on all cases. Yes,
Yeah.
exactly. That's what our intention was.
Okay.
All right. So I think with that we'll bid adieu. Thank you if you stayed this
Yeah.
far long. We thank you a lot, and
Yeah.
we'll be back with the
Yeah.
next
Thank
video.
you for bearing with my solutions. Yeah. We'll
No
we'll
worries.
join next time.
Okay. See you. Bye bye.